In this video, we will consider a few more examples of implicit differentiation. We will not find the equation of the tangent line to the curve at a given point. We'll simply find the derivative of the curve. So suppose we have the following curve. Let's go with x cubed minus xy equals y to the fourth power minus x plus 8. And again, when you have an equation of this type, all values of x and y, so all pairs of x and y values that satisfy this equation, will be a point on the curve. And you could visualize what this curve may look like using, for example, maple. But as always, we think of x as the independent variable and y being a function of x. So we think of y being a function of x, an unknown function of x. And now let's find the derivative. Well, both sides are equal as functions of x, so we can differentiate both sides. So the derivative with respect to x of the left-hand side, so x cubed minus xy, will equal the derivative with respect to x of the right-hand side, y to the 4 minus x plus 8. So let's differentiate. As always, be very careful when a term contains a y, because you have to apply the chain rule properly since y is a function of x. Let's differentiate the left-hand side. The derivative of x cubed with respect to x is simply 3x squared minus the derivative of xy. Here we have a product, so we have to apply the product rule carefully. Open your parentheses. So the derivative of xy will be the derivative of x, which is 1 times y, so we get y, plus x times the derivative of, and here since we only have a y, we'll have the derivative of y with respect to x, dy dx. So this takes care of the derivative of x times y. You can close your parentheses. And that's the derivative of the left-hand side of the equality. Let us now differentiate the right-hand side. Well, the derivative of y to the fourth with respect to x, so here you have to be careful, right? This is a y term, so apply the chain rule carefully. The outside function is the fourth power. Apply the power rule, so 4, and you bring the power down, 4. You subtract 1 from the exponent, 4 minus 1 is 3. And that's at whatever is left over, which is y, times the derivative of what's left over, which is y, so times the derivative of y with respect to x. There is nothing left over, so we are done with the derivative of the first function, minus the derivative of x with respect to x, which is 1, plus the derivative of 8, but since 8 is a constant, its derivative is 0. So now we're done with the differentiation. The rest will be algebraically solving for the derivative, dy over dx. Well, let's distribute here our negative sign. So we'll have 3x squared minus y minus x dy over dx. And this will equal 4y cubed dy over dx minus 1. Now, if you're hoping to solve for dy over dx, since it shows up on the left and on the right, you have to put all the terms that are multiples of dy over dx on the same side. So what we'll do is we'll send this term on the left-hand side of the equality, and we'll send the negative 1 onto the left-hand side. So what will that give us? Well, we keep the 3x squared minus y on this side. We send the negative 1 onto the left-hand side, becomes a positive 1, equals 4y cubed dy over dx. And now we send this term to the right-hand side, so it becomes a plus x dy over dx. And now we've regrouped every multiple of dy over dx on the same side. You could have sent this term over here and the other two terms over to the right-hand side. It doesn't matter. But you have to send every multiple of dy over dx on the same side. Then you can factor dy over dx. So we'll have 3x squared minus y plus 1 is equal to, factoring dy over dx from both terms will give you 4y cubed plus x. And now you want to isolate dy over dx, divide both sides by 4y cubed plus x, and we have our conclusion. The derivative of the curve dy over dx is simply equal to 3x squared minus y plus 1 over 4y cubed plus x. And there you have it. You have the derivative of the curve given by this equation of x and y is simply this. And you see it's always the same thing. So the first step is, remember thinking of y as a function of x. Since both sides of the equality are the same as functions of x, they have the same derivative, differentiate carefully, and then isolate algebraically your dy over dx. Let's do one more example. Suppose that we have the following curve. Let's go with x squared, y cubed, minus x to the fourth power equals 6y squared plus xy. Then again, we think of y being this function of x. So both sides are equal as functions of x. Since both sides are equal, they have the same derivative. Let's differentiate both sides carefully and then equate them. So let's differentiate the left-hand side. Here we have a product. X squared times y cubed, so we apply the product rule. Derivative of the first term, 2x, times the second term, y cubed, plus the first term, x squared, times the derivative of y cubed with respect to x again. By the chain rule, we have 3y squared times the derivative of the leftover term, which is y, so times dy over dx. And now we're done with the product rule and the chain rule, minus the derivative of x to the 4 with respect to x is just 4x cubed. That takes care of the left-hand side, equals the right-hand side. Well, let's differentiate this term. The 6 stays there, times, and again we have here y squared. With respect to x, we'll get 2y, chain rule, dy over dx, plus the derivative of xy, again the product rule. Derivative of the first term, which is 1 times y, so it's just y, plus x times the derivative of the second term. It's a single y, so all we have is dy over dx. And now we have the derivative of both sides being equal. Let's, as always, put all the multiples of dy over dx on one side, and all the other terms on the other side, and then isolate dy over dx. Since there are already two dy over dx's here, we'll isolate dy over dx onto the right-hand side. So let's see, 2xy cubed, that stays on the left, plus, well, negative 4x cubed, that also stays on the left. The positive y here we send on the left-hand side, negative y. And that takes care of every single term that is not a multiple of dy over dx. Equal to, well, here we have now 12y dy over dx plus x dy over dx And finally, now we send this term onto the right-hand side, so it becomes a negative 3x squared y squared dy over dx. And now, well, we factor dy over dx, and we're essentially done. So we have 2xy cubed minus 4x cubed minus y is equal to factoring dy over dx, 12y plus x minus 3x squared y squared. And our last step is to divide both sides by this expression, so we can isolate our dy over dx. So, the derivative of this curve is simply this function of x and y, so 2xy cubed minus 4x cubed minus y all over 12y plus x minus 3x squared y squared. And there you have it. The derivative of the curve happens to be this rational function of x and y. So always remember that no matter what equation you have that involves x and y, you think of y being a function of x, hence both sides are equal as functions of x, so the derivative of the left-hand side must equal the derivative of the right-hand side. Then you want to solve for your dy over dx, so put every multiple of dy over dx on the same side of the equal sign, then factor dy over dx from each term, and divide by the leftover multiple, and then you isolate your dy over dx. And that's it.